Hello, my name is Raymond Hartig. Today I would like to share my support for the Platonist theory in mathematics. Many of you may know this famous painting by Raphael titled The School of Athens. It was created during the peak of the Renaissance in Italy between 1509 and 1511. This masterpiece symbolized the union of art, philosophy, and science, and featured depictions of many of the most important mathematicians, philosophers, and scientists up to that time. Sharing center stage in this gigantic fresco are the prominent fathers of Western civilization, Plato and his student Aristotle. Aristotle can be seen with his hand hovering over the ground, giving the implication that he was rooted more deeply in the realm of a more realistic school of thought that is grounded in its nature. However, Plato can be seen pointing his finger up to the sky and the heavens above. This is no coincidence, as many of Plato's beliefs revolve around more ethereal and abstract concepts. The two of them standing next to each other in this painting represents the juxtaposition of their two schools of thought, not very different from the later established camps of rationalism and empiricism. This painting and its description of Plato illustrates the basis of the idea of the Platonist theory within the context of mathematics. Mathematical Platonism is often characterized by the viewpoint that the existence of mathematical logic and objects are entirely independent of human thought and language, and that mathematical systems are discovered by humans rather than created by them. Humans do, however, create the symbols that represent the complex concepts in and of mathematics, and this idea will lead to a very convincing argument in favor of the Platonist view of mathematics. There are three conditions that must be met by mathematics in order for it to be classified as Platonist. First, some mathematical ontology exists so it can be analyzed fundamentally and formally. Second, mathematical ontology is abstract. And third, mathematical ontology is independent of all rational activities, that is, the activities of all rational beings. These conditions are stated on the Internet Encyclopedia of Philosophy website, and I highly recommend further review if you're interested. Now, let's interpret these conditions through the eyes of ethnomathematics. The study of ethnomathematics is the relationship between mathematics and culture. This topic has gained significant interest in the past century. Ethnomathematics focuses on the development of mathematics in a peripheral sense to the conventional mathematics that was developed mainly in Europe and the Middle East throughout history. Two distinct ancient civilizations, the Maya and the Inca, are striking examples where the three criteria of Platonist mathematics are met. The Mayan civilization is a significant example of an independently developed mathematical system. The Mayans used a base 20 number system. They even developed the concept of zero, which is represented as a shell in their notation. The Mayan system possessed characteristics in their notation of dots, lines, and shells that create clear paths to addition and subtraction, something that the Roman numerals of the Europeans and Arabic numbers developed in the Middle East had not perfected at the time. On the same continent, however developed independently, the Incan culture founded a mathematical system called the Quipu. The Incans' mathematical system consisted of intricate knots on organic ropes that used a base 10 number scheme. Their system was greatly influenced by their geographical location and resource availability. High-altitude living created a difficult environment in which to survive, and it is impressive that they were able to creatively develop a mathematical system with the few raw materials they possessed. As stated earlier, both the Mayans and Incans developed their systems independently of each other and of other developing parts of the world, and it is very interesting to see that the Mayans used a base 20 system while the Incans used a base 10 system. As a side note, these two number bases do seem logical in a practical sense, however, because people have 10 fingers and 20 fingers plus toes, so it seems a reasonable assumption that counting was a main factor in the development of these ways of mathematics. While all of these systems are different notation-wise and discovered independently of each other, they all share the exact same fundamental mathematical structures and concepts. This is an extremely convincing argument in favor of a Platonist view of mathematics. First, two terms must be defined, the two nouns being the universal and the particular. Plato's theory of universals is central to the topic of Platonism in mathematics. in that universals are defined as abstract concepts that are separate from human thoughts and activities. Particulars also need definition. Particulars are more concrete and worldly entities that can change depending on where you are. Human ways of living are examples of particulars because if humans were to settle on another planet, that society would be fundamentally different than the ones on Earth, because that society's needs would be completely different. It is important to note that all three conditions must be met in order for an object to be considered Platonist, or in other words, as a universal. The fact that mathematical systems have the same underlying theory is key in the argument for it being a universal. In terms of ethnomathematics, we see very convincing evidence that mathematics is indeed a universal entity. Now we will examine this issue from the opposite end of the spectrum. In Plato's theory of universals, in order for something to be classified as a particular, it must be a particular instance of a universal, hence the name particular. Mathematical objects such as spheres and cylinders are extremely important in physics and many other subjects. However, those objects that we see are made up of matter, which is discrete in nature. This is different from the mathematical interpretations of these objects, which are continuous everywhere. Therefore, these are representations or approximations of the mathematical objects that they correspond to, and not the exact thing. Just as how we humans cannot know all the digits of pi because it is an irrational number, and even though irrational numbers exist in mathematics, they manifest themselves in our world differently. Infinity is a very tricky thing to comprehend, and that is probably because it is not really something that any of us can see or experience. Numbers, then, are examples of particulars and universals, since they both have multiple representations and a concept that does not change. Therefore, a Platonist viewpoint of mathematics seems to be an extremely logical viewpoint based in the fundamental nature of math itself. We can all be thankful for Plato's initiation of abstract ideas such as this, and intrigued by the civilizations of the Mayans, Incans, and so many more cultures around the world that help to demonstrate the notion that mathematics is larger than life, something all of us have in common, whatever form its reasoning style manifests itself in us. Thus, what was to be shown has now been shown.